Hi, my name is Oktay. Welcome to today's video about the chemical elements tellurium and polonium. This is a nice picture of a tellurium crystal on silvernite. Silvernite is silver gold telluride. The name tellurium comes from Latin tellus, which means earth. Atomic number is 52. There are 8 isotopes in nature. Most common isotopes are the radioactive isotopes 130 with 54% and 128. The isotope 128 has a half-life of 2 times 10 to the 24 years, and 130 has a half-life of 8 times 10 to the 20 years. This is a picture of nucleosynthesis of the origin of the chemical elements. Tellurium is here. It's a member of the chalcogene group. It is produced in dying low-mass stars and merging neutron stars. There is no known biological function of tellurium, but it can replace sulfur and selenium in amino acids, cysteine and methionine. This is a picture of the abundance of the chemical elements in Earth's crust. The y-axis is abundance in a logarithmic scale, and tellurium is here. A very rare element. Concentration is just 0.01 parts per million. And the reason is in the formation of the planet Earth, early phase, there was reducing conditions. So a lot of the tellurium reacted with hydrogen. You got hydrogen telluride, which is volatile and escaped into space. That's why it's rare in Earth, but in the universe it's more common. Tellurium was discovered in 1782 by Franz Josef Müller von Reichenstein in gold ores in Zlatna, Romania. And he had to work from 1783 to 1785 identify the new material as a new element, and that's why he called it metallum problematicum. These are 3 examples for tellurium minerals. At the left, that's native tellurium crystal from Vatukula gold mine in Fiji. In the middle, that's ammonite from the USA, which is iron telluride dihydrate. And at the right, that's telluride from Mexico, which is tellurium dioxide. There are 2 tellurium allotropes. Allotropes are different forms of the same chemical element. The stable allotrope is metallic tellurium, which is a semiconductor. And there's amorphous tellurium, which is brown solid, and it slowly converts to metallic tellurium. Melting point is 450 degrees Celsius, and the boiling point is 988 degrees Celsius. This is how you can make tellurium. It is isolated from the anode mud of copper ores. You can get 1 kilogram of tellurium from 1,000 tons of copper ores, and then it's purified with zone melting. That's the same procedure as with the isolation of the element silicon. The world's biggest producers in 2022 are China with 340 tons, that's 50% of the world market. Russia second with 80 tons, and Japan third with 70 tons. There's a compound cadmium zinc telluride, EZT, which is a semiconductor. This is an example for its use. That's the Boston Dynamics RoboDog spot has a radiation sensor of cadmium zinc telluride, and it is used in Chernobyl. This is an important use for tellurium. This is cadmium telluride, which is a semiconductor. This is a picture of solar panels with cadmium telluride. This is thin film technology, and 40% of the tellurium production goes into this process. Cadmium telluride has a small carbon dioxide footprint, a low water and energy usage, but cadmium is toxic. And this is a diagram of the solar cell efficiencies of the different technologies. And y-axis is efficiency, and x-axis is year of discovery. You can see the absolute top are the multi-junction cells with about 47%. Typical solar cell with silicon or cadmium telluride is here at about 22%. Another interesting candidate are the perovskites. They are not fully developed yet. And cadmium telluride solar cells make 5% of the global photovoltaics market. This is an example of the technology. That's a Topaz solar farm in California. It's a 550 megawatt photovoltaic power station. It is a $2.5 billion US project. There are 9 million cadmium telluride modules, and this power station has an annual output of 1,300 gigawatt hours. These are more applications for the element tellurium. 30% goes for the production of thermoelectric materials, for example, bismuth telluride, and it is used in metallurgy. For rubber, it has advantages over sulfur in the vulcanization process. It is also used for catalysts, for glass, for example, optical fiber, and you can use it for green fireworks. Tellurium in alloys improves the machinability and the mechanical properties and gives the alloy a better corrosion resistance. This is how you can detect tellurium compounds with hot concentrated sulfuric acid. This is the chemical reaction. 4 tellurium atoms with 3 sulfuric acid molecules. You get this tetratellurium ion plus water plus sulfur dioxide plus hydrogen sulfate. This ion is called Zintel ion. It is red and it is aromatic. At the right you can see the structure of this ion. It is flat and has 6 pi electrons. That matches the rule of Hückel's rule. It says 4n plus 2. That's why this compound is aromatic and it's red, and this is how you can detect tellurium compounds. And this is tellurium dioxide, TeO2. It is used for glasses with high refractive index. Refractive index means light bending ability. However, this compound could be teratogen. That's dangerous because teratogen means it is harmful to the embryo. This is another compound, organic compound, dimethyl telluride, TH3-2-Te, was discovered in 1939 as a metabolism product of bacteria and fungi. For example, fungus Penicillium isogenum. And this compound can be used for epitaxial growth of cadmium telluride. Epitaxial growth means making a thin layer, cadmium telluride, on a given surface. This is a picture of a RTG. That's a radioisotope thermoelectric generator. It contains the isotope polonium-210. At the right you can see this little spiral. That's a vent tube for the reaction product helium-4. Polonium was discovered in 1898 by Marie and Pierre Curie. They named it after the country Poland. And for this discovery, Marie Curie got the Nobel Prize in Chemistry in the year 1911. Polonium has the atomic number 84, and there are 42 radioactive isotopes. 3 of these isotopes are part of the decay chain of the isotope uranium-238. And see here, 218 polonium is a half-life of 3 minutes. And there's 214 polonium with a half-life of 164 microseconds, and 210 polonium with a half-life of 138 days. The alpha particle is a highly ionizing particle because it has a double charge. It is the nucleus of the helium-4 isotope. It cannot penetrate paper, but when it's incorporated, it's very dangerous because it is highly ionizing. World production of polonium is about 100 grams per year. This is how you can make it. By hitting bismuth 209 isotopes with neutrons, then you get bismuth 210, which decays to polonium 209 and the beta particle. Polonium 209 has a half-life of 125 years, and polonium is known to be very toxic. These are two applications for polonium. It was used for spark plugs and for static eliminators. And these objects are now in a museum, and I think that's a very good place for these objects. This is a nice crystal malonite, which is nickel telluride from Colorado, USA. This is a nice picture of ammonite, which is iron telluride dihydrate. These crystals have a size of 3 millimeters. This is from the Moctezuma mine in Mexico. And this is a nice monument of Marie Curie holding a model of the chemical element polonium in Warsaw. Yeah. That was today's video about the elements tellurium and polonium. Thank you for watching. Have a nice day. Bye bye.